Stop. Put down that wire brush right now. Every single time you scrub your delicate test sieves by hand, you are literally scrubbing away your accuracy, destroying the mesh, and throwing your lab's budget straight into the trash. If you want precise, reliable material testing results, it is time to upgrade. Today we are going to show you why ultrasonic sieve cleaning is the absolute only way to go. Welcome back to Certified MTP, your #1 destination for premium material testing equipment and expert laboratory insights. I am so glad you clicked on this video because today we are tackling a massive problem that plagues testing labs all over the world: sieve maintenance. Let's talk about blinding. Blinding occurs when particles from your aggregate, soil, or powder samples become tightly lodged in the openings of your test sieve mesh. When your sieve is blinded, the effective opening size is reduced. This completely compromises the accuracy of your particle size analysis. What is the natural instinct when you see a blinded sieve? You grab a brush and you start scrubbing. But here is the harsh reality: standard test sieves, especially those finer than a #100 mesh, use incredibly delicate, microscopic wire. When you apply the mechanical force of a brush, you are stretching those wires, altering the aperture sizes, and instantly pulling that sieve out of ASTM E11 So if we cannot use brushes, how do we get rid of deeply embedded particles? The answer is sound, specifically high-frequency ultrasonic sound waves. Ultrasonic sieve cleaners do not rely on friction. They rely on a fascinating physical phenomenon called cavitation. When an ultrasonic cleaner is turned on, transducers at the bottom of the tank generate high-frequency sound waves that travel through the cleaning liquid. These sound waves create alternating high-pressure and low-pressure cycles. During the low-pressure cycle, millions of microscopic bubbles form in the liquid. During the high-pressure cycle, these bubbles collapse or implode. This implosion is cavitation. When these microscopic bubbles collapse right next to the wire mesh of your sieve, they release tiny localized shock waves. These shock waves act like millions of microscopic scrub brushes, safely and effectively blasting away stubborn particles, oils, and dust from every single crevice of the sieve, without ever bending or stretching the wire mesh. The result? A perfectly clean sieve that maintains its factory calibration, ensures the integrity of your test results, and extends the lifespan of your equipment by years. Now that you understand the science, let's look at the absolute best tools for the job. First up in our equipment spotlight is a true workhorse in the material testing industry, the W.S. Tyler P1405 Ultrasonic Test Sieve Cleaner. If your laboratory relies heavily on standard 8-inch or 200mm test sieves, this is the precision instrument you have been looking for. The W.S. Tyler P1405 is engineered specifically for the precise dimensions of testing sieves. It features a compact, space-saving design that won't clutter your lab bench. But don't let its footprint fool you. It packs a massive punch. This unit provides intense, uniform ultrasonic energy, ensuring that even the most stubbornly wedged particles in your finest mesh are completely eradicated. What makes the P1405 stand out is its specialized focus. It is optimized to hold one 8-inch sieve at a time, making it incredibly efficient for labs processing high volumes of standard-sized sieves. The controls are intuitive and straightforward, allowing your technicians to set the cleaning cycle time and walk away to focus on other tasks. By using the W.S. Tyler P1405, you are actively protecting your investment in high-quality sieves. You are eliminating the risk of cross-contamination between tests, and most importantly, you are guaranteeing that your grain size analysis remains completely uncompromised. But what if your testing requirements are a bit more varied? Many geotechnical and asphalt testing labs utilize both 8-inch and the much larger 12-inch test sieves. For that, you need versatility. That is where our heavy-duty ultrasonic sieve cleaners designed specifically for 8-inch and 12-inch sieves come into play. These larger capacity ultrasonic baths are the ultimate solution for diverse laboratory environments. They are built with rugged, industrial-grade stainless steel tanks designed to withstand continuous, rigorous daily use. The larger footprint means you can easily submerge a massive 12-inch sieve, or in some configurations, clean multiple smaller sieves simultaneously. Because 12-inch sieves have a much larger surface area and often hold heavier, more stubborn aggregate materials, these cleaners are equipped with heavy-duty industrial transducers. They distribute the ultrasonic waves evenly across the entire expanse of the larger tank, ensuring there are no dead zones. Whether you are cleaning fine sand from an 8-inch sieve or coarse gravel residue from a 12-inch sieve, this machine delivers consistent, repeatable cleaning power. It completely removes the manual labor equation from your lab, protecting your staff from fatigue and your equipment from accidental drop damage during hand washing. Now, a lot of people ask me, can I just use plain tap water in my ultrasonic cleaner? The short answer is no. If you want to unlock the true power of your machine, you absolutely must use a specialized detergent concentrate for ultrasonic baths. Here's the secret behind the chemistry. Plain water has a very high surface tension. High surface tension actually inhibits the formation of those microscopic cavitation bubbles we talked about earlier. By adding the correct ratio of our specially formulated detergent concentrate, you instantly lower the surface tension of the liquid. This dramatically amplifies the cavitation effect, allowing the machine to generate more bubbles and more powerful implosions. Furthermore, test sieves don't just get clogged with dry dirt. They are often coated in natural oils, synthetic testing fluids, or fine clay that binds to the metal. Water alone cannot dissolve these contaminants. Our detergent concentrate is chemically formulated to emulsify oils and lift organic residues away from the brass and stainless steel surfaces without causing any oxidation or chemical corrosion to the delicate wire mesh. It is the crucial missing link in your sieve cleaning protocol. All right, we have our equipment. Now let's walk through the exact step-by-step process of how to use an ultrasonic sieve cleaner properly to ensure maximum lifespan for your testing equipment. Step 1. Preliminary cleaning. Never put a sieve full of heavy aggregate directly into the machine. Gently invert the sieve and give it a soft tap on the side of the frame with a wooden brush handle, never the mesh, to remove the bulk of the loose dry material. Step 2. Prepare the bath. Fill your ultrasonic tank with distilled or deionized water to the manufacturer's fill line. Avoid hard tap water as it can leave mineral deposits on your mesh. Next, add your detergent concentrate according to the specific dilution ratio on the bottle. Step 3. Degassing. This is a step most people skip, and it ruins their cleaning efficiency. When you pour fresh water into the tank, it traps dissolved air gases. You must run the machine empty for about 5 to 10 minutes to degauss the liquid. You will actually see the trapped air bubbles rising to the surface. Once the liquid is degassed, it is ready for optimal cavitation. Step 4. Submersion. Never place your sieve directly on the bottom of the ultrasonic tank. Doing so can damage the transducers and the sieve. Always use the provided suspension basket. Place your sieve mesh side down into the basket and lower it gently into the degassed solution. Step 5. The cleaning cycle. Set your timer. For regular maintenance, a 3 to 5 minute cycle is usually more than enough. Overcleaning is unnecessary and wastes time. Let the sound waves do the heavy lifting. Step 6. Rinse and dry. Once the cycle is complete, remove the sieve and immediately rinse it thoroughly under a gentle stream of clean, low-pressure water to remove any residual detergent and dislodged particles. Finally, let the sieve air dry in a clean environment. Never use compressed air to blow the mesh dry, and never place them in a high-heat drying oven, as the extreme heat can warp the frame and loosen the tension of the wire cloth. And there you have it. By abandoning the wire brush and implementing a proper ultrasonic cleaning protocol using the W.S. Tyler P1405, our large capacity 8 and 12-inch cleaners, and the right detergent concentrate, you will dramatically increase the accuracy of your sieving results and save your lab thousands of dollars in replacement costs. If you found this video helpful, please hit that like button and do not forget to subscribe to the Certified MTP channel for more deep dives into material testing equipment and lab best practices. If you are ready to stop damaging your sieves and want to upgrade your laboratory today, click the link in the description below to visit Certified MTP and shop our complete line of ultrasonic sieve cleaners and accessories. Thank you so much for watching, and we will see you in the next video.